Hello and welcome back to my YouTube channel. My name is Professor Gobala, and today I'm going to be talking to you about a complex source transformation example given to me by one of my subscribers. And essentially, we're going to do this in three parts. And what we're going to do is we're going to simplify the circuit using source transformation to get a single mesh circuit. And the second part of the problem tells us to solve for VO, given that I is equals to 2.5. And then the last part of the video is we want to basically simulate the circuit in LTspice and check that the VO that we get gives us a current of 2.5 amps. If you want to pause the video and try this out by yourself and come back to the video and see if you got the right answer, feel free to do so. So I've done a video of source transformation in the past, so I'm not going to dive too deep into how it works. But I will post a video on the top right hand side corner of this video, so feel free to check that out. I will be doing a lot of high level simplifications, so if you haven't checked out the past videos on source transformation, I would recommend to do that first before coming to this example. Okay, so what I'm going to do here is I'm going to consider that this here is A1 and this here is B1, and I'm going to consider that I can do a source transformation here. And with that source transformation, I can go ahead and add this resistor and this resistor. And then when I do a source transformation, this is going to become a voltage source. So I can add this voltage source and the voltage source that comes out of this current source. So let me go ahead and show you what I mean by this. So what I'm going to have here is I'm going to have a voltage source, and plus minus, because the current is going up, this is going to be 2 amps times 16 ohms, which is equals to 32 volts. Then I'm going to have a 16 ohm resistor here. And then I'm going to have a plus minus 8 volts here. And then I'm going to also have a 20 ohm here. And then this becomes this terminal and this terminal. Again, that's here. Let me call this A2. And here B2. So again, this is A2 and this is B2. And in between it is this 12 ohm resistor. So like I explained previously, I'm going to join this and this. So that's just an addition problem. So it becomes 16 plus 20, which is 36 ohms. And then this guy goes away. So it's just a line here. And I'm going to combine this and this. And since they oppose each other, it's going to be 32 minus 8 volts, which then becomes 24 volts. So then this then just becomes a straight line. Pause the video and make sure this makes sense. If it doesn't, please leave a question down in the comment section below, and I'll be sure to get back to you. Okay, so let's go ahead and write the rest of the circuit. So we can say then that this here is 3 ohms, right? It's connected to A1, and there is a 6 ohm resistor here. And then connected to that is this 10 ohm resistor right here. All right, and then on top here is this going downwards 3 amp current source. And then attached here is a plus minus V out. And then there's a 7 ohm resistor. And that's all attached to my 10 ohm resistor. And then there's a wire here connected to the 3 amp current source. And don't forget that my current I, which is equals to 2.5 amps per the problem, is flowing right there. Okay, so let me do some simplifications here again. This here can be simplified as a 3 ohm resistor in parallel with a 6 ohm resistor. And remember again, that's 3 times 6 over 3 plus 6, which is just essentially 2 ohms. So what I'm going to do is I'm going to go ahead and rewrite this as just a 2 ohm resistor. And as obviously 2 ohms is in series with 10 ohms. So then that just becomes one resistor of 12 ohms. All right. And again, we can see then that we have a current source in parallel with a 12 ohm resistor. All right. So that means that we can use source transformation again to change it to a voltage source in series with a resistor. All right. So let me go ahead and just erase this. Okay. And again, please feel free to pause the video, right? And make sure you understand everything that we're doing. So again, this is going to be a plus minus. The plus is going to be on the bottom because my current source was going downwards. All right. And it's going to be 3 times 12 because it's 3 amps times 12 ohms. And this becomes 36 volts. And then obviously this is 12 ohms here. All right. So what can we do next, right? We see that we have a voltage source and another voltage source in series. So we can add those up. And it looks like their terminals are facing the same direction, right? So plus comes before minus, right? And then we can also combine this 12 ohms with the 7 ohms because they're in series. So let's go ahead and do that. What I'm going to do is I'm going to actually just cancel this here. And I'm going to make this a wire. And I'm going to say 12 plus 7 is 19 ohms. And then here, I'm just going to simply add 36 volts plus V out. Again, we don't know what V out is, so it just stays as a variable. Okay, so let me go ahead and do another source transformation here just to give more practice. And say then that I can do a source transformation here, right, between A2 and B2. And that is because I have a voltage in series with the resistor. So then I can change this to become a current source going up because, again, the orientation of my voltage source permits me to do that. So then this is going to be in parallel with a 36 ohm resistor. And then this becomes 24, which is 24 volts divided by 36 ohms. Then that just becomes 2 over 3 amps. All right. So again, remember, this was A2 and this here is B2. And in between them is this 12 ohm resistor. All right. And then we finish this off with, again, this 19 ohm resistor attached to this 36 volts plus V out. All right. And what we can say here is that we have a current source of 2 over 3 amps in parallel with a 36 ohm resistor and a 12 ohm resistor. And the idea of going from this step, call it step 1, to this step was so we can combine this 12 ohm resistor with this 36 ohm resistor. So then what I would get is I'm going to do a source transformation right here. All right. And what I'm going to get is a voltage source. Okay. That is going to be 2 over 3, and this is amps, times 36 in parallel with 12 ohms, right? And then that's going to be in series with, again, this 36 in parallel with 12 ohms. And if I take a little detour, this is 36 times 12 over 36 plus 12, which is essentially 9 ohms. So this here is 9 ohms. Let me go ahead and erase this and just say times 9 ohms. And what I'm going to get is 6 volts. And this is in series with this 19 ohm resistor. So 19 ohm. And then lastly, minus plus, this is going to be 36 plus V out. And then we have our terminal here. And again, let me go ahead and write my current. So my current here, I, is flowing through here. And then again, now my current I is flowing through my entire circuit. So let's go ahead and draw this nicely and then also solve for V out. So then I can go ahead and write this single mesh equation, which looks like this. This again is this 9 plus 19 ohm. So then I get 28 ohms. And there's a voltage source here, minus plus, which is going to be 36 plus VO plus 6 volts. And that's simply because my 6 volts is orientated the same way as this voltage source. So we can just add them up together. And then this goes here. And since my current is flowing in this direction, I is equals to 2.5 amps. I'm going to say that this is my negative and this is my positive in terms of the resistor. So then I'm going to write a KVL equation. I'm going to solve for voltages across the circuit. And essentially, it's going to be 28 ohms times 2.5 amps minus 36 plus VO plus 6. And this has to equate to 0. 28 times 2.5 is 70. So minus 36 minus V out minus 6 has to equate to 0. If I move V out to the other side, I get that V out is equals to 70 minus 36 minus 6, which V out is then equals to 28 volts. So this is my final answer. So just to be specific, part 1 was right here. So this is the answer to part 1. It's a single mesh simplified circuit of my startup circuit. And this here is the answer to part 2. VO is equals to 28 volts. Okay, so now let's go ahead and simulate this in LTspice and see what we get for part 3. So this is the LTspice schematic. Again, I didn't want to show myself building this up because, again, it's supposed to be a complex example. So the viewer should be able to generate your current sources, your voltage sources, and your resistors. So that should be pretty simple. But we can go ahead and click on run here. And it's going to populate this configure analysis, right? And you basically have to tell it what you want to do, right? AC analysis, DC sweep. But what we want to do is this operating point, right? So .op and just hit OK. And what's going to happen is it's going to populate a .op here. And it's going to spit out our values. And what we get here is that the current through this R7 or this 7 ohm resistor is this minus 2.5. And again, that just depends on how LTspice decided to analyze the circuit. But essentially, that just means that the current is going the opposite direction of this minus 2.5 of its analysis. And we could also see that through V2 right here, it's this 2.5 amp current that's passing through it. And essentially what this proves is that our answer of V2 or V out equating to 28 volts generates a 2.5 amp current through it. So as a result, this makes sure that part 2 of our solution was correct. So I hope this makes sense. If you have any questions about any part of the video, please leave them down in the comment section below, and I'll be sure to get back to you. Please like and share the video to your colleagues. And if you like the content that the YouTube channel is providing, please consider subscribing. It really helps the algorithm. Thank you.